It turns out that figuring out which Wolfram class a particular rule falls under is not always very straightforward. Let's look at Rule 10. If I do setup and go, we see these jagged lines and these diagonal lines going down across the lattice. Well, it turns out that this is considered to be class 2, that it's considered to be a periodic pattern, just because we have this complete repeat of the pattern at each time step, except that it's translated over by a few steps. So this is considered to be a class 2 CA. It's relatively simple. And if we have a circular lattice, of course, the whole thing will repeat eventually. But the more important thing is that this pattern is repeating itself. The correct answer for this one was B. Now let's look at 128. That one's a little bit easier. If I now set my rule code to 128, do setup and go, you'll see that it always goes to a white fixed point. And that's because if we look at Rule 128, we can see that only an all black initial configuration will go to black. So for almost all initial configurations, this will go to all white. So the correct answer here, since it almost always goes to a fixed point of all white, we get class 1. Now let's look at Rule 22. I'll set the rule code to 22, setup, go. Well, it's not clear whether this is simply periodic or not. It turns out that Wolfram classifies this as class 3, that is, chaotic, random looking. Even though we don't exactly have a random looking array, we have these kind of triangular structures. But there's no long-lived particle-like structures as we saw in Rule 110. So this one was classified as chaotic, although it's not at all trivial to see why. So I'll mark this down as class 3, but don't feel bad if you didn't get that right, because it's not obvious to you as a casual observer of this which class this is in. It's even harder to say what class 4 is. This one is pretty vague. It's hard to tell between class 3 and class 4, and people have joked that class 4 are all the cellular automata that Wolfram himself calls class 4.